So at the end of this chapter, you're going to see a lot of different displays. Really, what you want to focus on is, can you understand what is being displayed to you? And then to close chapter 2, there's still this idea of, is this displaying my data honestly and truly, or is there a way to slant this depiction to make whoever's reading this data say something that it's not saying? So in the very first display, you have stem plots. Stem plots are not going to be used when you have a ton of data. What they are good in doing is keeping the actual discrete points visible. For example, I can actually still see in the table the number 75. So the stem part of a two-digit number is the tens place. So when I said I can see 75, I can technically see that there are 3 75s in the original list because I've got a 7 and then I've got 3 5s. So what the stem and leaf plot does for you is organize data from least to greatest. It's numeric data and quantitative data, and you can see that a lot of the numbers, more of the numbers are falling in the 70s. So there's still a visual display, sort of what a histogram does for us, but you can actually see the numbers that were originally in the list. A dot plot does something similar, but instead of showing the first digit and the second digit of a two-digit number, it displays a dot for every single number. You don't get to see every single number that was originally in the data set. However, you see that a dot plot can handle more numbers, that there are way more numbers being represented in this display than were in the stem plot. And so you see more of the shape. You can kind of get a shape with, you see my head going like this with the stem plot. You're like, okay, I can see there's more here. It was more linear. This is starting to get you more into like having a number line. And then now that's what's called bivariate data. It's like you got one set here, you got another set growing. And this is closer to the histogram that is the most important one in our course. And so it's just another way of displaying quantitative data. A time series graph has its benefits in that way, is that it shows a trend over time. So if you've got something that perhaps has seasonal changes, displaying the months of the year or the years as the horizontal axis instead of like a number line makes a lot of sense. Still, you are looking at a set of data that is quantitative, but you're seeing changes over time. Still has this display of change over, the numbers and the horizontal axis are still numeric and quantitative, but you're specifically looking at changes over an interval of time. So these charts are unique because of the fact that you can display categorical data. And the uniqueness also of this, what basically is a bar chart, is that whatever has the highest frequency is always displayed as that first bar. So you've got a frequency table, but two things that you see going on in this display of data is it's categorical data, still counting frequencies. But whatever was the highest frequency is highlighted as being in the first bar. It does show distribution, but the shape itself doesn't matter because the categories that are going along the horizontal axis are not organized or arranged numerically. So a pie chart is another way of displaying categorical data. And the expert in displaying data that this textbook is choosing to quote in this particular section really downplays the usage of pie charts. They waste ink even. This comes directly from the text. because again, you listen to what I said, the pros and cons were of the other displays is that they actually display the raw data somehow. As if you have millions of data points, you can't do that for every single data point, but there's still a way to keep true to the numbers and which numbers are occurring more often. Where they say when you look at a pie chart, that's kind of hard to tell. You start learning about circular shapes when you study fractions. And so I see weather and sabotage in this particular display are almost the same size, but it's really hard to discern, how much larger or smaller something is. So again, between these two displays of categorical data, at least this author is saying that the other chart on the previous slide does a better job. Don't use pie charts. And for this author, doesn't like pie charts. A frequency polygon, it reminds me a lot of the time series chart. However, it has specific points that are directly above numbers that are going along a number line. So the number line, as what I just finished saying, it's not time. It's not like months and years. The other thing is that it is just showing you specific data points, for the number of people that had 22. It's the ends of frequency, where it's very much like a histogram, but a histogram has bars. And so, again, take this lesson for what it is. It is meant for you to recognize the different displays that are out there to display your data and the pros and cons, and your ability to read them as you look at the example problems. So identifying which one might be better for different kinds of data, and then seeing if there are spikes and what those spikes in the diagram mean that the data is telling us. So they are going to cover, as I mentioned at the beginning, some ideas of bias, that there are things that are like bad graphs. The pie chart wasn't a bad graph. The message was just like, maybe it doesn't do as good of a job displaying the numbers. Maybe it's pretty graphic. But what we're trying to do when we gather data and come up with statistics is present information, and that's the numbers. So the importance of talking about bad graphs is so if we are being presented with data, we can identify things and analyze them critically and determine whether we are being misled. So this is under this part of the lesson called graphs that deceive. The other displays that were being shown were graphs that enlighten, that you've got this data and you want to present it. You've been doing a lot of work collecting all these numbers, and this is what you want to say that the numbers told you. But if you look at this deceiving graph, it appears on the left that OxyContin has way more percentage of people that experienced nausea compared to people that were taking the placebo, but that's because they didn't start at zero when they looked at the vertical increments. And by doing that, it made it appear as though OxyContin was way more of an effect than a nauseous effect than the placebo did. But when you look at the percentages aren't that far off. So when you look at the graphic on the left, it almost seems like the people that took the placebo had little to no effect of nausea, but in fact, that was like 10%, which you would have to be good with percentages to know that even still, that's not that much. But in comparison to 22, 25%, with people that took the OxyContin, that isn't as big of a multiplier. as it appears when the scale goes from 10 to 24 as opposed to 0 to 25 on the right side. So it's very deceiving if they don't start at 0. And then when they use the concept of multiplying to multiply an image. Again, this is deceiving visually because when you enlarge a two-dimensional shape, you enlarge both sides, both dimensions, so one dimension's linear and then two dimensions goes, I spoke a little bit about that bivariate data, you're going to have horizontal, you're going to have vertical. So if you expand both axes, then that's actually multiplying the area by more than twice. So that can be deceiving. So don't use pictures like that. You have numbers. There are ways to present the numbers. And so the author has these closing thoughts. The world desperately needs more people who can create original graphs that enlighten us about the nature of data. In the visual display of quantitative information, Edward Tufte offers these principles. If you have a small set of data of 20 or fewer, use a table. Let the numbers, that's enough numbers for people to try to analyze themselves. Your data should focus on the true nature. Your display should focus on the true nature of the data, not other things that are distracting, i.e. the telephone example that they just showed. Don't distort it. Try to let the numbers say what they say, and you're there to interpret it. You're there to make a visual display of what the numbers, as I mentioned earlier, are telling you. Almost all the ink in the graph should be used for the data, not for the title, not for other graphics. And again, remember that this all boils down to having a good sample. You don't want to present numbers that came from a bad sample. And so that closes chapter 2 about statistics and how they're displayed.